page 4 of Review Worksheet 2. So again, starting with number 16. So it wants us to graph the defined piecewise function. So our first function is we want to graph x plus 1. And we're graphing this on the interval where x is greater than or equal to -1. So on your graph, again on mine it's kind of hard to see. So when x is -1, that's this line right here. Everything past, so I'm saying when x is greater than or equal to -1, anything past that line, everything on this side of my graph, that's where I'm actually going to use this line. So this in this case has a y-intercept of 1, so I have a point right there. And then I want to get over to -1. So in this case, instead of going up 1 and over 1, I'm going to go down 1 and over 1. And since we're greater than or equal to -1, I can have, this is going to be a colored in dot over here. And again, I can go up 1 and over, and I'm going to do for one more point. Oops. Oh, it stopped. Okay, so up 1 over 1. That's that point right there. And that's annoying. But anyway, so from here, right, then we just draw our line. So for any number greater than or equal to -1, I'm using this line. And then I want to graph this one. So now I'm saying this one is going to be for all numbers that are less than -1, so everything on this side of that dotted line. So I'm graphing the line 2x minus 4. So I'd go down to 3, 4. So I would start here. That's my y-intercept. And then in this case, I would have gone up 2 over 1. So I'm going to go down 2 over 1. And in this case, I fall on that line. So that's an open circle. And then I go down 2 over 1. That's right there. And then down 2 over 1. And my graph's a little, the grid lines are gone. So in this case, but it would look something like that, where this open circle is at -1, and this closed circle on my other function is at -1. Okay. So domain, this is again is the leftmost part of our graph to the rightmost part of my graph. So in this case, this arrow indicates that we go down, down, and down, and down forever and ever and ever. So my domain, I can go as far left as I want. And then up until here, I have a point here. Even though it stops here, I have a point in order to pair there. It just jumps up to my other line. And then I can go to infinity. So my domain on that is -infinity to infinity. And then range is the lowest point of my graph to the highest point of my graph. So again, this part tells me I go down and down and down forever. So I can go all the way from -infinity. And then following my line up, notice I stop here. I stop when x is, the ordered pair on that is -1, -6. So in this case, it's hard to tell on my graph, but that's this ordered pair right there. So I can go all the way from -infinity until my y value on that, which is -6. And then I jump up here, which is when y is 0, because the ordered pair on that is -1, 0. So then from 0, then again my line goes all the way up and up and up forever and ever. So I can go all the way from 0 to infinity. So my range is -infinity to -6, and then from 0 to infinity. That's my range. So x-intercepts, this is where it crosses my x-axis. So again, right here, remember, I have a point that's at -1, 0. That's actually my x-intercept. So I have an x-intercept at -1, 0. And then my y-intercept is where it crosses the y-axis. And that ordered pair right there, remember, that was at 1, 0, or 0, 1. So my y-intercept is at 0, 1. So getting better with these, I know it takes some time, but okay, so that's number 16. So number 17, we want to be able to actually write our own function based on a graph. So in this case, we want to write a definition for this function. So the first thing I'm going to look at, I'm going to look at this line right here. And I'm going to say, okay, well if I was going to write the equation of that line, is I'd go down 1, 2, 3, 4, 5, 6. I'd go down 6. And then I'm just going left and right from that. So in this case, that's actually going to be that's a horizontal line. at y, remember this is y equals negative 6. And then for my interval on that, so I'm going to use that line if. I want to say, well, what x values are, like, is it between? So in this case, the x value on this point right there is negative 8. So x is between negative 8 and my x value over here, that is 0. And in this case, right, so we're saying everything that's less than 0, so x is less than 0, strictly less than because this is an open circle. And when x, in this case, has to be greater than or equal to negative 8, so x is greater than or equal to negative 8. So that case takes care of this part of our graph. Now I want to focus on this one. So this one, again, it's hard to tell on my graph because my grid lines are faded. But my y-intercept on this point right here is at 0, 3. So I know in the equation of this line, it's going to have a plus 3 on the end. And then looking at this, so on your graph, notice if I were to go up 1 and over 1, it wouldn't fall on my graph. So if I go up 1 and over 2, I actually hit on my graph. So this has a slope of positive 1/2. So the equation of this line is 1/2 x plus 3. And again, I'm going to use this. Notice if I look at this line, it doesn't stop anywhere. So I'm actually going to use this for all x values that are greater than or equal to 0. Because this is when x is 0, and I'm using it for all x values that way. So that is the definition for this function. So moving on. That's number 17. Numbers 19 through 22, we're going to graph these using transformations. And on these, it's nice to show at least 3 points so you can kind of get a good picture of where this graph is going. So if we're looking at this one, we have a negative x minus 1 cubed plus 3. So the first thing I notice is I have a plus 3. That means for sure I'm going up 3 somewhere. Up 3, which is right there. And when something is in with my x, that tells me that I'm actually, normally like when you see minus 1, we want to go this way. But when it's in with the x, it's actually the opposite way. So I'm going to go up 3, and then in this case, over 1. That's going to be the vertex of whatever this is going to be. And my function is x cubed. So normally I'd go up 1 and over 1 to find that first point, and down 1 and over 1 to find my other point. But I have the negative out in front. So that tells me I have a flip going on in here. So again, instead of going up 1 and over 1, I'm going to go down 1 and over 1 to find that first point. And I'm going to go up 1 and over 1 to find my other point. So again, if you weren't sure where to put those points, there's no harm in actually plugging in points. So if I didn't know this point was here, if I plugged in when x is 0, when I say x is 0, so we're going to get 0 minus 1, which is negative 1. Negative 1 cubed is negative 1. Or in this case, yeah, so 0 minus 1 is negative 1. Cubed is negative 1. Then I have to take the opposite of that, which is positive 1, plus 3, which is 4. So notice at 0, 4, I have my point there. So again, plugging in points will always work too if you can't remember your transformations. And then, so same thing. So if I wasn't sure what was happening when x is 3, I could plug that in. So 3 minus 1, which would be 2. Cubed, which is 8. And then the negative of that is negative 8. Plus 3, which is negative 5. So I'd go x1, 3, and then down 5. So that would be that other point right there if you were to actually plot that too. So then drawing the equation of my line, I'd go down and then through this last point. And that's sort of what that line would look like. Okay, so if you were to go to a graphing calculator, we could graph that, but we want to do these by hand. So this next one, I have nothing going on outside, so I know I'm not shifting up or down, but I do have this negative 1 on the inside with my x. So instead of going left 1, that tells me I'm going to at least go right 1. So my vertex is going to be there. or the point where I start my graph is going to be right there. And then, so this is a square root, so I know it's going to look like a shooting star. But notice I have a 2 on front. So that tells me I'm going to actually, it's going to be vertically shifted. Or not shifted, it's going to be vertically stretched. So normally on my square root function, I'd go up 1 and over 1. But since I have multiplied by 2, I'm going to go up. So again, if you weren't sure, I could plug in 2. So if I plug in 2, 2 minus 1 is 1. Square root of 1 is 1. Times 2 is 2. So I'm going to go over 1, up 2. Instead of over 1 and up 1. And again, normally for that next point, we go over 4, up 2. In this case, we're going to go over 4, up 4, which is right there. And then, since I filled my graph, I'm actually going to then just draw my function. So that's what the square root of that would look like. Number 21. In this case, again, I'm going to look for where I'm shifting my graph first. So I know I'm going to go up 4. 1, 2, 3, 4. I'm going to go up 4. And the negative 1 on the inside tells me I'm going to shift right 1. So I'm going to start here. And I know I'm not going to be going up because I know this negative tells me I have a flip. So I have a flip going on up front. And this 3 tells me I'm going to vertically stretch it. So normally we'd go over 1 and up 1. And the flip tells me I'm going to go over 1 and down 1. But the 3 tells me I'm going to go over 1 and down 1, 2, 3. So my second pair of points is going to be right there. And I'm going to over 1 and down 3 on the other side. So those are where those points are. And again, from here I could go over 1, 2, 3 to find even more points. Over 1, down 3. And then just going to draw the line. Because remember, absolute value is going to look like a V. So this is what this one is going to do. Ooh boy. And again, that's not the greatest graph, but you get the picture. So in this case, I have a V opening down, vertically stretched by 3, flipped, and the vertex is at 1, or the origin, the new origin is at 1, 4. Okay. So number 22, first thing again, as I see I have a minus 2. So in this case, I'm going to go down 2. I'm going to be somewhere in here. And this plus 3 tells me I'm going to shift left 3. So left 3, I'm going to go down 2. 1, 2, 3. So this is where I'm starting my graph from. And then nothing else is actually happening with this. I'm not vertically stretching, I'm not flipping because nothing's out in front of here. So now I can just graph x squared where I normally would go. So on my pair graph, I would go over 1 and up 1. So I'm going to do the same thing on this one, over 1 and up 1. And then my next set of points were over 2, up 4. And if you weren't sure, you could plug those in, over 2, 4. And then I'm just going to draw in my graph. Because this is going to look like a parabola. It's going to look like that. Alright, so that's the end of page 4. So if you want to stay tuned, the rest of page 5 is coming on up.